Hello, this is Tim O'Connell from the Department of Natural Resource Ecology and Management at Oklahoma State University. For the next few minutes, I'm going to show you how you can calculate the Shannon Diversity Index using Microsoft Excel. Remember, this is the diversity index that's probably standard use by ecologists for comparing different sites in terms of their diversity. And diversity in this case includes not just species richness or the number of species, but a measure of the abundance of individuals of those species. So what Shannon Diversity Index allows you to do is examine or compare, as we're about to do here, these two sites in terms of the evenness of the abundance. So are one or a few species really much more abundant than all the others that are present? Or are the species more or less equally distributed in terms of their abundance? If it's the latter case, that almost all the species are about equally abundant, that's the highest diversity you might expect. And if you have a case in which one or two species are much more abundant than other species, that reduces what we call evenness and actually lowers the diversity index score that you get. The calculation of Shannon Diversity Index is actually really easy in Microsoft Excel, and all it takes is setting up the data just the way you need to make it easy, and then to use some really basic Excel skills like inserting a function in a cell and then sort of filling that function down through a column. Once you do that, you're going to see it's going to be really easy. The background data that I'm using here come from a state wildlife grant-funded research project from eastern Oklahoma that surveyed freshwater mussel species at 6 different sites within the Poteau River watershed. I've got 2 of those sites represented here, and what we're going to do is calculate Shannon Diversity Index for each of them. Here I've got my data set up in a table to help me do the calculations for Shannon Diversity Index of freshwater mussel data from sites 5 and 6 from a study in the Poteau River watershed. I've got common name and site 5 and then some other columns here. The common name here, those are the common names of the different mussels that were found in the survey. In column S, where it says site 5 here, those are the abundances of each of those species that were documented in that particular survey. And what I want to know, ultimately, to do the calculation is the proportion of all the individuals of all the species made up of each individual species in this sample. So I want to know like how many total individuals of all species there are, and then what proportion are those 50 washboard mussels out of that total. And when I do that, I can run through some other calculations. The next thing I would do is take the natural log of that number and then multiply the proportion times the natural log of the proportion, and that'll give me the information in column W. And then take the negative sum of that, and that's the Shannon Diversity Index. So here's how this is going to look. First, I'm going to want the total number of all the individuals. And to do that, equals sum. We're going to sum the number in a column. So equals sum, parentheses, and there you go. 113 total individuals. Here I'm counting up the number of species. So there were 11 species total at site 5. Next up, I'm going to do this column U, which is proportion of the individuals of each species out of 113. And then once that's known from the top cell, I can click and drag from the bottom right corner and fill in that same function all the way down. So this is our real time savings here. Now the natural log. The function here is ln parentheses, and just click on that cell in column U and then drag the corner and fill it down. Next is the product. Product is easy. It's just parentheses, click, and then asterisk for multiplication, and then click the other cell, and there you go. Now, getting the natural log of the proportions actually changes the sign to a negative. So to sum this, we're actually going to take the negative sum to change the sign back to a positive, and just sum the information in column W. That gives us a Shannon Diversity Index value of 1.794. Next, we want to know, is that, good? And to do that, we want to divide by, take the ratio of the maximum possible diversity we could have. And that's 2.398. That 2.398 is the natural log of species richness. So now we know that site 5, 0.748, or about 75% of the maximum possible diversity. Let's do that for site 6 now. We'll get all the sum of all the individuals of all the species. And that's 189. Here the number of species is, drum roll please, 13. There we go. And let's get those different columns. Column U, the proportion of individuals of each species out of the total 189 individuals. Fill that down. The natural log of the information in column U. The product of columns U and V. And then the natural log there, and then we take the sum, the negative sum, of column W. There we go. And that's Shannon Diversity Index 1.865. How high could that index score have been with maximum evenness? To know that, again, natural log of, in this case, 13, which is the species richness, and that's 2.565. Get that ratio, 1.865 divided by 2.565. Then we can convert this unitless measure of diversity into something that can make sense to us. And there we go, about 73% of the total maximum possible diversity at site 6. So both of these sites, pretty diverse.